The measurement of angles is fundamental to trigonometry, and there are two units of measurement that are frequently used today: degrees and radians. In this video we're going to look at and compare both of those measurements. Now it's essential to understand both degrees and radians, the differences between them, and how we can convert between these two measurements when we're working in computer graphics and programming. Degrees are perhaps the most common measurement of angles outside of mathematics. Therefore, it's common to find that 3D applications will use degrees as a measurement of rotation, for example. However, as we're going to discover in this video, radians are far more frequently used when we are dealing with mathematics. Mathematicians like radians. And because of this, one will find that maths libraries included with programming languages are often going to use radians to represent angles for their various functions, such as the trigonometric functions, for example. Now, in addition, some of these libraries do provide alternative versions of these functions that take degrees as parameters if they're angular parameters, return degrees if they're returning an angle. So understanding the differences between these two measurements, how we can convert between them, and how we can work with both of these measurements is going to be essential for utilizing all these different maths functions, whether they take in radians or take in degrees, and for applying them to angular parameters in 3D applications that almost certainly are going to be in degrees. Now, as I previously mentioned, degrees are perhaps the most common measurement of angles found in our everyday lives. For example, latitude and longitude values use degrees as a form of measurement to locate a point on the surface of the Earth. Degrees are used to represent bearings in navigation. And there's a common English phrase for describing a complete change in attitude towards something, and that's to say that the person has done a complete 180, referring to 180 degrees being the angle that someone would need to turn through in order to be facing in the opposite direction. Degrees are so well known, in fact, that it's probably redundant to describe them here, but just in case you're unfamiliar with degrees as a measurement of angle, here's a really quick overview. So let's say that we had some string. We had a piece of string, and that piece of string was attached to a pin. Now, if we kept that string tight, pulling against the pin, we know that we could rotate the string about our pin. And if any rotation about that pin, the string is going to have moved through a certain angle. Now, the degree unit of measure defines one complete rotation, that is, the angle that we need to rotate through to bring our string all the way back to the starting point. It describes one complete rotation as 360 degrees, and degrees are noted with a small circle just above the angle number. So 360 degrees is one complete rotation. Logically, therefore, half a rotation is going to be 180 degrees because we need to rotate through half of the angle that we would for a full rotation. Again, logically, a quarter rotation is going to be 90 degrees. And that's really all there is to degrees. One full rotation is 360 degrees. Simple. Now, degrees have been used for thousands of years, since the time of ancient civilizations, so it's really no surprise that they're still used today and that they're so common. And because everyone is familiar with degrees, it really does make sense that 3D applications, for example, use degrees to represent rotations, because the users that are working with those applications, they're going to be familiar with degrees, they understand degrees, they most likely think of angles in terms of degrees. Therefore, it makes sense that these applications are using degrees to represent rotations. However, mathematicians, they found that this choice of 360 as an arbitrary constant for the measurement of one complete rotation, it's just a little bit untidy when the mathematics get a lot more complicated. And it's hard to show this without examples that would be far beyond the scope of this DVD, but by adopting a different unit of measure, mathematical calculations relating to angles seemingly become more elegant and a lot easier to work with. So introduced in the 1700s, the angular measurement used by mathematicians to this day is the radian, and that is spelt R-A-D-I-A-N, the radian. Now, technically speaking, the term radian itself wasn't introduced until the 1800s, but the concept behind radians was introduced in the 1700s. Now, whilst one can argue for and against the use of radians, the fact is that today the radian is the standard unit of measurement for angles with mathematics and physics, and that suggests that there is a consensus out there that radians are preferred over degrees because they are the standard unit of measure. But what exactly are radians? Well, the mathematical definition of a radian, which can seem a little confusing, so do bear with me, is that it's the angle created by a circular arc whose length is equal to the circle's radius. Now, what on earth did that mean? It's a lot easier to show as a diagram than as a spoken sentence. So let's say we had some imaginary circle out there, and we know that circle is going to have a center point and a radius. Now, if we were to rotate this radius through an angle of 1 radian, it's going to define a circular arc. So between the start and end points, which we know are both length of radius, it's going to define a circular arc that itself has the length of the radius. So the rotation needed to define a circular arc that has the length of the radius of the circle is 1 radian. So you'll find that radians are often written as a number followed by rad or rad for radian. They can also be written as 1 with a small c, which is very similar to the degree symbol, but it's a c rather than a complete circle. I personally avoid writing radians like this and prefer, if I'm going to give a unit of measure, writing them as rad, just because the c can get confused with degrees, especially if we're writing quite small. But you'll often find that quite frequently when we're dealing with radians, and you're going to see exactly why in a second, but when we're dealing with radians, the unit of measure, the angle if you will, often has a term of pi in. And because radians will have a term of pi, whereas degrees almost certainly will not have this term of pi within their measurement, we're going to find that often you may see a rotation written as, 4 pi. If you see this, you know instinctively it's in radians, even if there isn't a unit given, simply because pi goes hand in hand with the measurement of radians. Now, this definition, the definition that the measurement of radians, a single radian, is the angle we need to rotate through to get a arc length equal to our radius, it may seem a little unusual and it may seem hard to remember. So to make it easier to remember how radians relate to rotations, and to help us convert between degrees and radians, let's consider the definition of the circumference of our circle in addition to the definition of a radian. And that's going to help us to see a really nice fact, if you will, a really nice number that's a lot easier to remember than the mathematical definition of a radian. Now, what do we know from volume 1 when we looked at the circle? What do we know about the circumference of our circle? Well, we know that the circumference, which I'm going to name c, of a circle is equal to 2 pi r. So that's the full circumference. That's a distance we need to travel to go all the way around our circle. Now, how many radians, therefore, would be in a complete rotation? Well, we know that 1 radian, a value of 1 as our angle when we're measuring it in radians, gives us an arc length equal to our radius. Therefore, if we know that we travel 2 pi r in a complete rotation, and that r is a rotation of 1 radian, if we divide 2 pi r by our radius, by r, it's going to tell us how many radians there are in a complete rotation. And we can see that both of our radius values cancel each other out, and that there are 2 pi radians within 1 complete rotation. And you can see now, because so often pi is inside the number, if you will, of our angle when we're measuring in radians, you'll often just see, oh, it's an angle of 2 pi. It won't actually say, oh, it's an angle of 2 pi radians. And because it just says it's an angle of 2 pi, we instinctively know it's radians, because radians and measurements of pi go hand in hand. So 1 complete rotation, 360 degrees, is equal to 2 pi radians. So 360 degrees is equal to 2 pi. Logically, therefore, 180 degrees, a half circle rotation, is going to be equal to half of our value for 360 degrees, which means 180 degrees is equal pi radians. 360 degrees is equal to 2 pi radians. logically 90 degrees is going to be equal to pi over 2 radians. And there's actually another relationship that I'd like for you to remember, and that is that 3 pi over 2 radians is equal to 270 degrees. We can see that if 90 degrees is pi over 2, 270 degrees, 3/4 of a circle, is going to be 3 pi over 2. So if you try and remember these 4 relationships, it's really going to help you out. Obviously, the most important one is remembering that 360 degrees is equal to 2 pi radians. If you remember that, you can work out all of the others. However, if you can remember that 180 is equal to pi, 90 degrees is equal to pi over 2, and that 270 degrees is equal to 3 pi over 2, it's going to make life a lot more easy when we're working with radians, because if you see, oh, this is a rotation of pi, you instantly know, oh, that's 180 degrees, and you can just convert back and forth really quickly in your head. Now let's take one of these relationships, and I'm actually going to take the relationship of 180 degrees is equal to pi, because therefore we just have pi on its own. We don't have 2 pi or pi in a fraction. We just have pi on its own, and that's equal to 180 degrees. If we took one of these relationships, we could rearrange this relationship in order to convert back and forth between degrees and radians. So let's say 180 degrees is equal to pi radians. Well then, how do we find what 1 radian is equal to in degrees? Well, if we have pi radians over here, we need to divide by pi to get 1. If we're dividing this side by pi, we'd better divide our other side of the equation by pi. And that means 180 degrees divided by pi is equal to pi over pi. This cancels down and becomes 1. Which means that 180 degrees over pi is equal to 1 radian. Well, hopefully it's therefore obvious that if we wanted 2 radians, we'd need 2 times 180 degrees over pi. If we wanted 3 radians, we'd need 3 times 180 degrees over pi. Therefore, to convert from radians to degrees, we multiply our radian value by 180 degrees over pi. Or in other words, we divide by pi and then we multiply by 180 degrees. And we can test this. We know that 3 pi over 2 radians is equal to 270 degrees. So if we wanted to convert from radians to degrees, let's check this. We said we have to multiply by 180 degrees over pi. In other words, we divide by pi and then multiply by 180. Well, 3 pi over 2 divided by pi is going to become 3 pi over 2 pi. These both cancel each other out, giving us 3 over 2. If we multiply that by 180, well, 3 times 180 is 540. 540 divided by 2 is 270, and we can see indeed that is correct. So again, to convert from radians to degrees, we multiply our radian value by 180 degrees divided by pi. We can rearrange this the other way. We can rearrange this to convert from degrees to radians. If we went back to our original 180 degrees is equal to pi, I'm going to bring up a new whiteboard to do this. So if we went back to that original relationship that 180 degrees is equal to pi radians. So we saw how to convert from radians to degrees. We had to work out what 1 radian is equal to in degrees. Let's do the same now, but for degrees into radians. Let's find out what 1 degree is equal to in radians. How do we get this side to be 1 degree? We must divide by 180. If we're going to do that to the left-hand side, we'd better do that to the right-hand side as well. We can see both of these cancel, giving us, as I erase this quickly, so that's still divided by 180, giving us 1 degree is equal to pi over 180 radians. So 1 degree is equal to pi over 180 radians. That means if we want to convert our value in degrees to radians, we multiply our degree value by pi over 180, or in other words, we divide by 180 and we multiply by pi. So to convert to from degrees rather to radians, we multiply by pi over 180. We can test this again. I'm going to convert 90 degrees to radians. So we take 90 degrees and we multiply it by pi over 180. We saw that's the same as dividing by 180 multiplying by pi, so that's equal to 90 divided by 180 is a half, multiplied by pi, which we could write as pi over 2. We know that 90 degrees is indeed equal to pi over 2 radians, so we can see that this is indeed correct. So again, to convert from degrees to radians, we multiply by pi over 180. To convert from radians to degrees, we multiply by 180 over pi. So we have two conversion factors, and logically one is the reverse of the other, because if we want to go from degrees to radians, we better take the opposite set of steps from going from radians to degrees. So logically they are the reverse of each other, and these two conversion factors are very, very useful. If you can't remember them, then at least remember how to get from 180 degrees is equal to pi radians, how to get from that to these two conversion factors. Because if you want to convert a value from radians to degrees or vice versa, let's say we have a rotation in a 3D application that's in degrees, but I need that in radians to pass to a maths function, you're going to need to remember and use this conversion factor. So even though the conversions are very simple, I do want to set two very quick questions for you to work through on your own. So after setting each question, you're going to have the opportunity to pause the video and attempt to answer the question on your own. Once you have a solution, or if you get stuck, unpause the video and I'm going to work through the solution on the whiteboard. That will allow you to check your answer, or if you did get stuck, hopefully allow you to see where you went wrong. So I'm going to scroll down just a bit. And question 1 is simply going to be to convert 1080 degrees into radians. So go ahead and pause the video, convert 1080 degrees into radians, and when you unpause the video, I'm going to work through the answer on the whiteboard. Okay, welcome back everyone. So, yep, very simple. We're converting from degrees to radians, and we know that our conversion factor for converting from degrees into radians is to multiply our degree value by pi over 180. That means we're going to divide by 180, and then we're going to multiply by pi. So that means we're going to take our 1080, divide it by 180, multiply that by pi. Well, 1080 divided by 180 is 6, so that means that 1080 degrees is 6 pi radians. So that is the answer for question 1. Now, I did not wish to delete everything. There we go. So if you did get that answer, if you did get 6 pi, well done. If you didn't, then make sure you were indeed using the correct conversion. The conversion from degrees to radians is to multiply by pi over 180. Make sure you did have the correct conversion, and then make sure that you did actually work out the conversion correctly. I should note that you may well have put this into a calculator and got some value that's around about, I guess, 18 point something, because pi is around 3.14. So you may have got a value that wasn't in terms of pi, but all the time we're working on the whiteboard, I like to keep our rotations in terms of pi. Everything's cleaner and more accurate. But if you did get a value that used a calculator to get around 18 point something, then obviously that is the correct answer as well. So there's question 1. Let's move on to the final question. So we've just converted from degrees to radians, so it's going to be pretty obvious now that I'd like you to convert from radians to degrees, and I'd like you to convert 5 pi over 9 radians into degrees for me. So go ahead and pause the video, give this a go, and when you unpause the video, I'm going to work through a solution on the whiteboard. Okay, welcome back everyone. So our conversion factor here is to convert from radians to degrees, and that's a conversion factor of 180 over pi. That means we need to divide by pi and then multiply by 180. So 5 pi over 9 divided by pi, both of those pi's are going to cancel to give us 5 over 9, multiplied by 180. That's the same as, well, 5 times 180 is 900. So that's 900 over 9, which is equal to 100. degrees. So there is our answer. So 5 pi over 9 radians is equal to 100 degrees. Alright, so to recap, we've seen two different methods for measuring angles. We've seen degrees and we've seen radians. 360 degrees is one complete rotation, which is equal to 2 pi radians. We've also seen how we can convert between both degrees and radians and degrees, how we can convert back and forth between those two measurements. Now again, this is very, very useful to know, as often when we're programming, the maths functions that take angles as arguments or return angles as parameters are going to use angles that are defined in radians. Now it's worth mentioning the documentation for the programming language in the libraries you're using should specify whether these functions are dealing with angles in radians or degrees. So if you're never sure, then definitely jump into the documentation and have a look to see, because it will tell you, oh, this function is using angles as radians, or it may even tell you this entire math library is using functions as angles as radians. So always look at the documentation if ever you're unsure. But you're going to find that most often maths functions are going to use angles measured in radians, but we've mentioned that our parameters in 3D applications or other user input angles in our own programs, they're more likely going to be in degrees, because non-mathematicians understand degrees a lot better than they understand radians. Many non-mathematicians don't even know what radians are. That's understandable. They're used in mathematics, so you only expect mathematicians to know them and work with them. So understanding the difference between these two measurements and how to convert between them is going to be essential if you want to take user input values that are in degrees, convert them to radians to apply them and use these maths functions that are taking radians in. You're going to need to be able to convert. If those maths functions give you radians out, but you need to convert them back into degrees to present them to the user, you're going to need to convert the other way. So understanding both of these measurements and converting between them really is essential. And I truly hope that this video has provided exactly that knowledge for you today. So thank you for watching, and I hope you enjoyed this video.